Hello, my name is Ademola Owunkoko, and in this video, I'll be presenting um, programming for data analysis. Um, for analysis, where we are given a data set to perform some data handling. We have to import the data, do some data processing, data visualization, exploratory data analysis, and perform data modeling, and finally develop an app. Right. So the data set talks about um, the air pollutant, hourly air pollutant across different monitoring sites, across different over region over different years. And the data handling, uh, I imported the data set, which I'll be showing in the IPMB file later on. I imported the data set and then loaded it to merge it by concatenating it and then view the rows and the columns, just doing basic preliminary check. And then also on data handling, I try to understand data, how many rows, how many columns, I understand the data type, is it string or float or object, and then seeing the missing value basically, and then went on to perform some pre-processing. I did four major feature engineering. I converted the wind direction to wind angles. I also converted the hourly time to time series and date time, right? So we are able to perform time series analysis. I also converted filling the missing value. Last feature engineering which I did was to uh, also develop an AQI, generate the AQI, that's the air quality index for each station. Mm, and I'll be showing that in the IPMB file also. And lastly, I fill in the missing value based on how they are distributed, or how the features are distributed. So for features that are skewed, I use the median, and for those that are unskewed, I use the mean to fill in the missing value. And then I did the visualization, and I did the modeling, which I'll be showing, and develop an app on Streamlit. And then lastly, I did the version control, which I'll be showing on uh, my GitHub. So I committed all this over the version control by committing it with analysis, a description on my Streamlit. And going to the IPMB file, I also so like I said, I imported the application into my drive, and then connected my Google Colab, mounted it on my Google Colab basically, and then loaded the data set after importing the necessary libraries, all the files, and then merge the data set by concatenating using this line of code, and then perform some basic PDs to understand the shape, the columns, and then the basic inform is it integer float, uh, is it is integer float or, objects basically, and then do some processing. The first processing I did was to do the feature engineering where they converted the date to date time. So in order to perform the time series analysis, and then you can see the date, and then also find the missing value in percentage, in heat map, and then try to see the distribution of the features uh, to in order to perform filling the missing value. This is still the same thing I did here, just in different visualization. And then here for the one that are skewed, I use the median. For the one that are skewed, I use the mean. Uh, then went on to convert my wind direction to wind angles, and then you can see that here, some vision, and then went on to visualization, where I did visualize different pollutants across different stations. From visualize selected different pollutants across different stations, and you can see it is highly interactive. And then because of my time, I'll be moving from here. Also, I did the heat map distribution just to understand, get more insight about the application, about the data, and then you can see uh the I also did the it correlation heat map of the pollutant. You can see that PM2.5 and PM10 is highly correlated, and then you can see the effect of the wind angles on the pollutant, right? You can see that it shows that most frequent wind direction associated with each pollutant is northeast. It is northeast for most of the pollutants. And then most of the time I'll be moving on to see other visualizations where you can see here the uh, pollutant is much more dominant during the winter and less dominant during the summer. And the most dominant pollutant is also the CO, basically. And I'll be moving, and here I also did the HEI calculations based on the breakpoint of China MEP standard, and we see that the HEI is highest at Dongji. HEI equality index is highest in Dongji. And lastly, I go on to the modeling. I went on to modeling where I used where I standardized the data. First, I standardize the independent variables after using the selecting PM 2.5 as my dependent variable. And then the algorithm I used is linear regression, um, linear regression to then after using linear regression, I used KNN with Crystal CV. So when I use linear regression, I got my RMSU to be 33.5, and then when I did KNN with my Crystal CV, it reduced to 25.12, and then finally I used random forest to also fine tune it. And then of course the value did not really change. It was also around 25.8, and that's it about the application. And then I went on, I also built my app using the Streamlit. I've already uploaded the data set. Uploaded the data set because it took time. That's why I had to break the video into two. After uploading the data set, and it's loaded this automatically. And then here you can view the HDA and click on here. You can view the HDA to see if you are viewing the statistical summary. Here you can view the statistical summary. See the minimum, and then you can see the basic statistic. Basically, you can see the box plots of the number depending on the one you want to see. This one, because I selected number, that's why you can see number like this, the distribution of number. If you select let's say distribution of PM 2.5, you can see PM 2.5 box plots for PM 2.5 and the distribution of PM 2.5, right? And if you select, say, PM 10, or let's say CO, say distribution of CO, both in box plots and this distribution like this. So you can select as many as possible. That's the basic statistics. You can also view the correlation. If you click on correlation, and view the correlation of the application of the correlation. Basically, select temperature. Select, let's say, select temperature on the X plot. This is, for example, you can select temperature, and you can select PM 2.5. Select PM 2.5 in this place. Let's say select PM 2.5. For example, you can see the scatter plot for PM 2.5. You can see the scatter plot for PM 2.5. And you can see the correlation. So of course you can also view the distribution analysis. The distribution analysis. See, select choose, and then when you choose, you can see 2.5. See distribution 2.5 also. And you can see the for the numerical, that's for the numerical, and for the categorical, you can see the distribution of the wind direction for the station. See the distribution for the station basically, and also so it basically is customizable depending on what the user wants to see. Of course, you can see the missing value that was of the data set that was uploaded. You can see the percentage of the missing value. and you can see the missing value, the distribution of the missing value. CO has the highest percentage of missing value, right? And so that's that about that. Then you can proceed to do the processing, and then so depending on what you want to process, so you can decide to do the mean, median mode, and you can just decide to drop a column. And of course, that's one form of processing. You can decide to use the Z-score or IQR, but to handle the outliers. You know, to handle the outliers, I just want to. And the rest can also, of course, can also do the feature scaling just like we did. Can standardize data or can do the robust feature scaling. And of course, you can then, depending on what you, the feature you want to view. Okay, which feature do I want to drop? I want to drop the win column. Let's say I drop the win column, for example. I drop the win column, right? So I can apply this pre-processing. I can apply this now. After applying it, you can see it has been applied successfully, and that's why the win column has been done. So you can also download this as a CSV and download this as a CSV. Now, depending on what you want to do, the user wants to do, you can also decide to select any other feature depending on what he wants to do, right? After just because of our time, I'll be proceeding into the modeling. So we have different modeling. We have the linear regression. It is basic. We have the ridge regression, and the ridge regression is basically used in estimating the coefficient of multiple regression models. And in the scenarios where the independent variables are highly correlated, right? Where the independent variable are highly correlated, but here we have the dependent variable to be highly correlated. And also we have the lasso regression, where is a method that is being used to perform both the variable selection and then the regularization of variable selection and regularization, right, to enhance the prediction analysis. So it does two things at the same time. It does the variable selection and the regularize at the same time, right? And then we have the random forest, and then we have the SVR, and we have the XV. But for the purpose of this video, I'll be using the linear regression, and then of course you can train the model. You can see the RMSE is 1.2, and we have the RMA R squared to this, and then you can see the actual versus the predicted value. So basically that's about that. And then you can see, of course, you can select another model. Let's say select random forest. Select random forest. But this might take time because let me reduce it. Reduce, so it will not take much time to load it. Test size to be just 11. Then let's reduce this to 20. So let's train the model. Let's see what we have. Running. So you can see the RMSE is 1.2 or so, and then you can see the feature importance. So this is my application, and of course you can download the result of the process data, the data model, and of course the trained model. Yeah, thank you very much.